Assalamu alaikum and very good morning to all of you. Today in the subject physics for grade 8 students, we are going to start the new lesson, that is chapter 36, electromagnetic induction. In this we are going to start the lesson from the page 296. So let's open the page 296. We are going to see the lesson today, that is chapter 36, electromagnetic induction. In this there are some objectives, that means what we are going to study in the today's lesson. That is, first thing is about the introduction of electromagnetic induction by Michael Faraday, and the second thing that we are going to know about how does this electromagnetic induction works, and the third thing is the Fleming's right hand rule. So these are the three things that we are going to study here. So let's talk about one by one. Firstly, that is about the introduction of electromagnetic induction by Michael Faraday. So let's talk about the introduction. So electromagnetic induction was first discovered and way back in the 1831 by Michael Faraday. Faraday noticed that when he moved a permanent magnet in and out of a coil or a single loop of wire, it induced an electromotive force. We call it as EMF. In other words, we also call it as voltage, and therefore current was produced. So this is about the electromagnetic induction. So the phenomenon of electromagnetic induction, the phenomenon which is about the electromagnetic induction is we are talking about the phenomenon where inducing the voltage by changing the magnetic field around the conductor. And the Faraday found that if a wire is moved across lines of flux, then a current is induced in the wire if there is a complete circuit, and this is called the electromagnetic induction. There are the ways the current can be increased by using a stronger magnetic field, and other is by moving the wire faster. If the wire is not moving, there is no current. It is the meaning of that. If the wire is not moving, it means that if the wire is not moving, there is no current. So this is about the electromagnetic induction. Now we are going to talk that how this is working. So here is a diagrammatic representation which is given to you for the how does it works. So here is the movement in the current. This is the south pole, this is the north pole of the magnet, and here is a sensitive galvanometer is attached here. So now we will see that how does it works. When the magnet shown below in this diagram is moved towards the coil, the pointer or the needle of the galvanometer, which is basically a very sensitive center zeroed moving coil ammeter, will deflect away from its center position in one direction only. When the magnet stops moving and is held stationary with regards to the coil, the needle of the galvanometer returns back to zero, as there is no physical movement of the magnetic field. So stationary, here the term we are using the stationary. Stationary means which is fixed, not moving. So when the magnet stops moving and is held stationary with regards to the coil, the needle of the galvanometer returns back to zero, as there is no physical movement of the magnetic field. So this is about the diagram. And also likewise, when the magnet is moved away, if we are moving this magnet away, then what happens to this? When this magnet is moved away, this is the magnet which is being moved away, then from the coil in the other direction, the needle of the galvanometer deflects in the opposite direction with regards to the first, indicating a change in polarity. Then by moving the magnet back and forth towards the coil, the needle of the galvanometer will deflect left or right. and this is positive or negative relative to the directional movement, directional motion of the magnet. So this is about the magnetic movement or in the coil. So now let's talk about the next, that is about the Fleming right hand rule. How this Fleming right hand rule it works. So look at the diagram. If you are looking at the diagram, this is the thumb movement, and this is the first finger field, this is the second finger field, this is the movement of your finger. So you are pointing this towards the upward direction, and this is towards the direction to the next. Now let's talk about the how the Fleming right hand rule works. So the Fleming right hand rule, it is here. We are using Fleming right hand rule to hold your right hand in a fist and then spread out the thumb, first finger and the second finger, so that they are at right angles to each other. Point your first finger in the direction of the magnetic field from north to south. Rotate your hand about that finger until your thumb points in the direction of the movement of the wire. Then your second finger points in the direction of the current. So here this means that when you are pointing these fingers, it is making a right angle. Right angle means the angle which is making here the 90-degree angle between the two fingers. So here the fingers, that is the first finger and the second finger, they are moving in the direction of the magnetic field. So this is all about the Fleming right hand rule. So here the Fleming right hand rule is used to remember the direction of the induced current. How the current is being induced, that can be known by using this Fleming's right hand rule. So this is all about the Fleming right hand rule. The Fleming right hand rule, as I told you, that when there is a movement, the point when you are putting your thumb in the upward direction and point your first finger in the direction of the magnetic field. So the first finger you are pointing towards the magnetic field, that is from the north to south, and rotate your hand about that finger until your thumb points in the direction of the movement of the wire. Then your second finger points in the direction of the current. So this is all about the today's lesson about the introduction for the electromagnetic induction, and with how does it works, and how the scientist Faraday has given an idea in the year 1831 about the electromagnetic induction. This is all about the today's lesson from the page 296. I will be back with the furthermore, and till then, thank you and goodbye.